So before we get started, let me quickly walk you through today's agenda. First, we'll talk about how to monitor the performance of your cloud applications, so you can catch any issues early and keep things running smoothly. And then we'll dive into end-to-end visibility for serverless applications. It gives you insights into how they are performing and where improvements can be made. Next, we'll cover how to track key KPIs across container orchestration platforms. And finally, we'll look at ways to detect and resolve performance kind of issues. So next, let's look at some key industry insights. 24% of enterprises are using the cloud. So this tells us that cloud adoption is no longer a trend, it's the standard. Businesses across industries are moving their operations, applications, and infrastructure to the cloud for scalability, flexibility, and cost efficiency. So the market value of the cloud industry is projected to reach $678 billion by 2025. So this growth is driven by increased cloud adoption, digital transformation initiatives, and the need for robust IT infrastructure. And by 2028, the market is expected to grow even further to $1.26 trillion. So this indicates a strong demand for cloud-based solutions. But with rapid growth comes challenges, especially in managing performance, security, and reliability. As businesses continue to grow and scale their cloud infrastructure, so the need for reliable performance and proactive monitoring becomes more and more important here. And that's where cloud monitoring solutions really make a difference. They help track key metrics, minimize the downtime, and ensure efficient use of resources. And in today's webinar, we'll explore how we can achieve this in a multi-cloud environment. As we started adopting these technologies, it's crucial to ensure and monitor the performance of cloud applications, which is the focus of our first topic. So these are some of the major cloud platforms that enterprise use today. Each of these platforms play a key role in digital transformation, and also it helps businesses scale and innovate. In Applications Manager, we monitor several cloud technologies, including Amazon Web Services, Microsoft Azure Cloud, Oracle Cloud, Office 365, and Google Cloud. So these technologies are available as a comprehensive monitoring bundles. And when I say that, I mean they come with everything you need to get full visibility right out of the box. So now let's take a look at how Applications Manager helps monitor the cloud applications and as well as the containers. Applications Manager integrates with various cloud platforms and gather performance metrics through API requests. So it works with native cloud monitoring services like AWS CloudWatch, Microsoft Azure, GCP Suite, and OCI monitoring. So these services provide crucial insights into different cloud resources, such as cloud compute instances, containers, databases, servers, and serverless components. So the collected data is processed by the metric aggregator, which plays a key role in analyzing and consolidating the performance metrics. This data is then used for fault management. It allows users to detect and resolve issues in the real time. Additionally, analytics feature provides in-depth reports and trends to help optimize the cloud performance. So the users and administrators can access all these insights via the Applications Manager console. This ensures continuous visibility and proactive control over the cloud infrastructure. It helps businesses maintain the high availability and monitor their entire performance. Applications Manager, we monitor a wide range of AWS services to ensure seamless cloud operations. So with this, we can track performance, availability, and resource utilization. Generally, it helps businesses stay proactive in troubleshooting and optimize their cloud infrastructure. Now let's take a look at how Applications Manager integrates with AWS to monitor the cloud resources. So this diagram illustrates how it fetches key performance metrics using the AWS SDK and then the API calls. Initially, Applications Manager integrates with AWS using the AWS SDK to fetch the key performance metrics. So it utilizes the API calls like describe instances for EC2, describe volumes for EBS, and describe DB instances for RDS to retrieve the real-time status and as well as the insights. Similarly, it gathers storage details from S3 using the list buckets and messaging insights from SNS with the list topics. So finally, all these collected metrics are processed using the getMetrics statistics. So all these APIs are helpful to fetch the information, and the API in the CloudWatch, this allows for efficient monitoring and as well as the proactive troubleshooting for AWS resources. So far, we've seen how Applications Manager monitors various AWS services using the AWS SDK. Now let's shift our focus to Microsoft Azure. So in this screen, we displayed the supported services for Microsoft Azure. Totally, we support 42 different services in the Microsoft Azure Monitor. Just like AWS, Applications Manager offers deep monitoring for a wide range of Azure services. This ensures optimal performance and availability is in place. So now let's take a look at the different Azure services that we can monitor in the Applications Manager. Initially, we will discuss about the discovery methods used in the Microsoft Azure. So there are three different authentication methods that we can use to retrieve the data from the Microsoft Azure. So initially, we'll discuss about the Active Directory application and then the service principal. So in this method, the user must create an Active Directory application in the Microsoft Azure portal. And then we need to provide the client credentials, which includes the client identification and as well as the client secret. So once these credentials are configured, an access token is generated using a separate API call. So this access token is then used for authentication and then retrieving for the monitoring data from the Microsoft Azure. And mode 2 is Microsoft Azure organizational account. So with this method, the user provides the Microsoft Azure credentials, which includes their email address and as well as the password. So using these credentials, an Active Directory application is automatically created and its client credentials are retrieved through a PowerShell script. Similar to the first method, an access token is generated via an API call, and this token is used for authentication and then the data retrieval process. And finally, we have OAuth authentication. So in this approach, open authorization is configured using the client credentials. So instead of relying on fixed credentials, this method dynamically generates a rotational access token, specifically the authorize and then the token endpoints. This enhances security by ensuring the credentials aren't exposed for long. So these three authentication methods provide flexibility in integrating with Microsoft Azure. Now let's move forward and see how Applications Manager utilizes these authentication methods to gain deep visibility into the Microsoft Azure portal. So now we will discuss Microsoft Azure 365 services monitored within the Applications Manager. And once that is completed, we'll be able to understand how we are utilizing these resources in the Applications Manager console. As we discussed previously, let us look at how Applications Manager helps in monitoring the Microsoft Azure and as well as the Microsoft 365 services. So Microsoft 365 is a widely used cloud-based productivity suite. And also it ensures its availability and performance is crucial for the business operations entirely. So with Applications Manager, we can monitor the key Microsoft 365 services, including Microsoft Exchange Online, Microsoft SharePoint Online, and then Microsoft Teams. When I say Microsoft Exchange Online, so using this, we'll be able to monitor and track the email flow and mailbox usage, and then the email latency to ensure smooth communication. And then we'll move on to Microsoft SharePoint Online. So this helps us to monitor the site collections, storage usage, and then the access patterns. These informations will be helpful for seamless collaboration. And finally, we have Microsoft Teams. So it provides insights into call quality and meeting performance, and then the user activity. So with this monitoring capabilities, businesses can proactively detect issues and optimize the Microsoft 365 environment. So Microsoft 365 Monitor. So using this, now let's dive deeper into how we can monitor Microsoft 365 services using the Applications Manager in a different perspective. So first, we'll discuss how we will be able to monitor the overall health and performance. So we continuously track the availability and performance of Microsoft 365 services to ensure uninterrupted business operations. And second, proactive user and license monitoring. So we keep an eye on user activity, the license usage, and then the allocation. So this helps us to optimize the cost and then the resource usage. And then we have comprehensive Exchange Online monitoring. So by tracking the mail flow, mailbox performance, and then the email latency, we help businesses prevent communication disruptions. And then we'll be able to track the critical SharePoint metrics. So using this, we analyze the storage usage, access trends, and site performance. This helps us to ensure a smooth collaboration experience to track the SharePoint metrics. And then finally, we'll be able to quickly detecting and resolving the performance kind of issues. So with real-time alerts and analytics, we help businesses identify and fix issues before they impact the end users. So now let's take a look at the Applications Manager console, and we'll see how we'll be able to monitor these kind of metrics and then the attributes in real time. Once you've logged into the Applications Manager, you'll see a UI similar to this. So this is the dashboard where you can monitor and manage various applications and then the various infrastructure components. Now let's say we want to onboard a new monitor type. It's really simple, and we just need to click on New Monitor from the top menu. You can see this opens up a list of all the monitor types supported in the Applications Manager. Applications Manager supports over 160 plus technologies covering cloud services, databases, servers, applications, and much more. So for this demo, I'm selecting Microsoft Azure Monitor here. So once we selected the Microsoft Azure Monitor, we'll begin with Azure Cloud Monitoring and Applications Manager. So this will allow us to gain deeper visibility into Azure services, track performance metrics, and ensure smooth operations of your cloud environment. As we discussed earlier, you can see that the options that are available here, the three different authentication methods available to retrieve the data from the Microsoft Azure. So the first method is AD application and service principal. So this is the most secure and preferred approach. It uses Azure's service principal to access to access and monitor the resources from your Azure portal. So here we have a step-by-step process to integrate the Microsoft Azure within the Applications Manager. So it starts with creating a Microsoft Entra application, fetching the required application IDs, assigning roles, and finally adding the monitor. So each of these steps ensure that Applications Manager can securely fetch Azure metrics, and also it provides the real-time monitoring insights. So these are all, it's kind of a prerequisites that needs to be configured before onboarding the monitor. So once the prerequisites are completed, we can good to go with onboarding the monitor. When I select add new monitor, you'll be able to see the steps, the options that is required to onboard a monitor here. So the first one is like the display name. So we just need to enter a name for easy identification for your Azure monitor. And second one is subscription ID. So in this subscription ID, we need to paste the Azure subscription ID to link the monitor to your Azure account. And third option is Azure services. So from here, we need to select the specific Azure services that we need to monitor. By default, all supported services are selected here. Fourth option is account type. So when onboarding Azure Monitor and Applications Manager, you'll see an option called account type here. So this defines which Azure environment your account belongs to. Let's go through the options here. So first, we have Azure Global. So this is the standard public cloud used by most organizations worldwide. Next, we have Azure Government Cloud. So Azure Government Cloud is nothing but it is a standard public cloud used by most organizations worldwide, and also it is designed for government agencies. It's offer enhanced security and compliance with the regulations. And third option is Azure China. So this is a separate version of Azure specifically built to follow the China's strict data regulations. Then we have a discovery mode option. So using this discovery mode option, the options that are available is AD application and service principal, and OAuth and Azure organizational account. So as we discussed earlier, we have three options to discover the data. So these are the modes that are available within the Applications Manager to establish a connection from the Applications Manager installed server to your target machine, the Azure server. And finally, we have the option called child monitor discovery. If you want to monitor your child monitors, we can select this option. First, discover and manage. So this detects child monitors, but keeps them unmanaged by default. Next, discover and monitor. So this is the default option. It automatically detects and starts monitoring all the child resources. And finally, we have discover and monitor based on rejects. So this allows to filter and monitor only specific child resources that match your rejects pattern. And under the advanced settings, we have these kind of options. So the first option is to retrieve the data collection API. So this helps Applications Manager to try again automatically if a data collection attempts fail. Then there is an alert on resource creation and deletion. So this option is enabled. If this option is enabled, you'll get notified whenever a new resource is added or an existing one is removed within your Azure environment. And next, we have an option called action on deleted resources. So this defines what Applications Manager should do if a monitored resource is deleted in the Azure environment. So you have 4 options to choose from. And finally, we have action on deleted resources. So using this option, you'll be able to continue alerting. So like alerts will keep coming even after the resource is deleted if you select the first option. And second one is stop alerting. Alerts will stop, but the resources stay in the console. And then we have unmanaged resource option. So the resource won't be pulled anymore, but it stays listed here. And finally, we have delete resource option. So if you select this option, the resource will get removed from the Applications Manager completely. And for the timeout seconds, we can set the default timeout seconds as 300, and discovery interval is 5 minutes. So for each and every 5 minutes, we will try to discover the newly added metrics that are available within your Azure portal, and then it will automatically fetch the information and it will show in the Applications Manager UI. And finally, we have polling interval. So we can set the frequency in minutes for data collection. So the default polling interval is 5 minutes. So for each and every 5 minutes, we will try to establish a connection to your Azure portal, and we will retrieve the real-time information, and it will automatically discover, and it will be visible within your Applications Manager UI. So finally, we have the option called test credentials. So once all the informations have been provided, we can click on test credential. If the credentials are passed, we can good to go with onboarding the monitor. So these are the steps to onboard the Azure monitor within your Applications Manager instance. So once the Azure monitor is onboarded, the monitor will be presented like this. Under the monitor information, you will be able to view the detailed informations like what are the informations we have provided while onboarding the monitors. You'll be able to list all the information, view all the informations here. And under the overview tab, you'll be able to view the detailed informations of your Azure monitor, like the availability history for the last 6 hours, and then the performance history for the last 8 hours. Like you'll be able to view the detailed informations here. And under the analytics, you'll be able to view the detailed insights into your Snaps workspace within your Azure environment. And under the containers, you'll be able to view the number of Azure Containers apps and as well as the Azure Container registries. So these are all like real-time informations that are pulled from your Azure portal for each and every 5 minutes based on your polling interval. So these are like basic informations that will be available under the overview tab. And apart from this, if you want to deep dive into your Azure portal, we can click on each and every tabs here. So under the analytics tab, you'll be able to view detailed insights into your Synapse workspace within your Azure environment. So initially, you'll be able to view the workspace name, the name of the Azure Synapse Analytics that is being monitored. And second one is like you'll be able to view the resource group name as well. So the associated Azure resource group where the workspace is located, you'll be able to view those informations here. And apart from this, you'll be able to view the location and as well as the provisioning state here. And the real-time informations of this Synapse workspace health history will be available within this view. So if you want to configure the alarms for each and every Synapse workspace, we'll be able to configure the alarms. Like if the health of this particular workspace is in the down state, we'll be able to get an alert from here itself. Like we'll be able to configure the alarms from here itself. Apart from this, if you want to check the compute details, like your Azure compute resources, we'll be able to view including your service plans and as well as the Azure app services details like web apps. And apart from this, if you want to look at the functions, what are the functions that are being visible within your Azure portal, we'll be able to view those informations as well. And finally, you will be able to view the list of virtual machines that are available within your Azure monitor. And if you want to verify the VM scales, these are the major metrics that is available within the Azure monitor. So each and every monitor has a separate options to configure the alarms. Like if you want to configure alarm for each and every metric, the option is available within this monitor itself. And if you want to view the container details, like the container apps and as well as the container registries, you'll be able to view those informations here. Apart from this, if you want to list the Kubernetes cluster, you'll be able to view the cluster status here. If it is in the running status, you'll be able to view the current status real-time information within this containers tab. And then the database tab, it provides an overview of various databases services like Cosmos DBs, MariaDB, and MySQL, PostgreSQL, and then the Redis caches. So along with their health and then the provisioning state, you'll be able to view the performance metrics as well. So we can also configure alarms for each database separately to ensure proactive monitoring and then for issue resolution. Integration tab provides insights into various Azure integration services, including Event Hub clusters, Event Hub namespaces, and then the logical apps. So if you want, if it enables monitoring for key performance metrics, you'll be able to view the key parameters such as the real-time status and as well as the provisioning state. And apart from this, if you want to verify your messaging workflows, we'll be able to view those informations here. Under the network tab, we'll be able to view the comprehensive view of Azure networking resources, including application gateways, load balancers, firewalls, virtual networks, and express route circuits. So this helps in monitoring connectivity, and as well as we'll be able to secure and the traffic distributions will be across your cloud. We'll be able to monitor across your cloud environments. So users can track key parameters such as a status and then provisioning state and then the resource location for efficient network management. And if we enter into the security tab, it enables monitoring of key vaults and then the managed HSMS, the hardware security modules. So it provides insights into provisioning status and as well as the resource health. Users can track encryption key management and secure secret storage as well. Under the storage tab, you'll be able to view the insights into your backup vaults and standard and premium storage accounts. So when I say premium storage accounts, you'll be able to view the storage sync services. It enables efficient monitoring and management of your storage resources. So users can track provisioning status, health, and performance. So this helps us to ensure data and then the availability is secure within your Azure environment. Then we have a billing tab. So under the billing tab, you'll be able to view the daily expenditure in a graphical representation view. And apart from this, if you want to check the billing summary, you'll be able to view the current billing cycle. And if you want to view the detailed informations of top 10 costs by the services, each and every services, it will be listed here. And apart from this, if you want to view the breakup of your cost by the services, it will be listed here. So for each and every services, we'll be able to configure the alarms as well. If there is any service costs that is exceeded a limit, we'll be able to set an alarm within this tab. And finally, we have management tab. So under the management tab, it provides insights into your subscription quotas and then the usage of those quotas. And apart from this, you will be able to view the client secret expiry details as well. So this section helps users to track their Azure spending, and also it helps us to forecast the future cost as well. So this is Microsoft Azure Monitor. Once we onboarded the monitor, these are the informations that are being visible within the Applications Manager UI. Now we move on to the serverless application monitoring. As businesses move towards modern cloud environments, serverless computing has become a key part of application development. So serverless applications allow organizations to run code without managing the servers, making them high scalable and cost efficient as well. However, with this flexibility comes the challenges of monitoring the performance and tracking the resource usage and ensuring the seamless execution. So in the upcoming slides, we will explore how Applications Manager helps in monitoring serverless applications efficiently. Before we diving into serverless monitoring, let's understand the key architecture shift in the modern architectures. When I say serverless monitoring, we need to understand the key architectural shift in the modern applications as well. Moving from monolithic to the microservices architecture, on the left, we see a monolithic architecture where the GUI business logic and the data layer are tightly coupled within a single code base. This means any change or update requires modifying and redeploying the entire application, making it less flexible and harder to scale. On the right, we have microservices architecture, where different components of the application are broken down into independent services. So each services runs its own logic and communicates with other through APIs. So this approach provides better scalability, faster deployments, and improved fault tolerance. So with the rise of microservices and serverless applications, monitoring has become more complex nowadays. So in the upcoming slides, we'll explore how Applications Manager helps in efficiently monitoring and managing these modern architectures. So serverless monitoring with AWS Lambda. Now let's see how serverless monitoring works in real-world AWS Lambda environment. Let's take a look at this diagram. It shows an event-driven architecture where different AWS Lambda functions handle specific tasks based on the triggers. So Applications Manager integrates with Amazon CloudWatch to collect and analyze the performance metrics. Now, when an event happens, CloudWatch automatically triggers the right AWS Lambda function, which then carries out a specific action. For example, one function, when it updates the inventory in AWS DynamoDB whenever a purchase is made. Another function handles order dispatch once all conditions are met. And third function sends an email notification using the AWS SES, simple email services. Since serverless applications scale dynamically and run only when it is needed. So it's crucial to monitor their performance, latency, and execution status in real time. So this diagram will explain how this works in a real-time world. So tracking critical KPIs in container orchestration. Now let's talk about monitoring key performance indicators, KPIs, for containerized environments. Containers have become the backbone of modern application deployment. And also, container orchestration platforms like Kubernetes, Docker Swarm, and OpenShift help manage them efficiently. However, to ensure smooth operations, we need to track critical KPIs as well. So in the upcoming slides, we'll be able to track and see how these KPIs are being monitored within the Applications Manager. Containerized orchestration platforms. When I say containers, so the containers have been transformed the way applications are built. Not only built, like deployed and then managed. But when working at scale, we need robust orchestration platforms. Let's take a look at three major players in the space. First, Docker, the pioneer in containerization. It allows applications to be packaged and run anywhere. And second one is Kubernetes, the industry leader in container orchestration. It offers automated deployment, scaling, and then management as well. And finally, we have OpenShift, a Kubernetes-based platform with enterprise-grade features. And also it has a lot of security enhancements as well. So each of these platforms play a unique role in modern IT infrastructure. So when you're working with containers, we need to make sure they are running smoothly and efficiently. So we all have a question, right? Why is container monitoring important? So when we comes into containers, we need to make sure everything is running smoothly and efficiently in real time. So that's where monitoring comes in. It helps us to stay on top and avoid unnecessary headaches. Like first, will ensure availability and then the performance. If a container goes down or starts lagging, monitoring helps us catch it before it affects the end users. It also helps with scaling. Containers are designed to scale up and down dynamically. But without proper monitoring, we might either over provision and waste the resources as well. Another big advantage is like identifying issues quickly. So containers are constantly spinning up and shutting down. The problems can come and go in within a seconds. So the monitoring helps us catch those issues before they become major problems here. Then there's the security. Containers introduce new security risks, and monitoring helps us to detect any vulnerabilities before they can be exploited within your environment. And finally, we'll be able to optimize the cost. So the cost optimization is one of the major role here. If you're not keeping track of resource usage, we might end up paying for containers we don't actually need. So we'll be able to monitor all these metrics within the applications manager. Now let's explore the KPIs monitored in the OpenShift. Now when it comes to OpenShift, there are several key performance indicators, KPIs, that we need to monitor. So in Applications Manager, we automatically track important metrics like node details, pod details, containers, services, and jobs. So these KPIs give us a complete picture of how OpenShift is performing and help ensure everything runs smoothly. We have a general question here, right? So how we will be able to discover the OpenShift within the Applications Manager? There are two ways to do this. The first one is SSH method, and next one is Prometheus method. The first method, SSH, uses a connection. If you have an SSH connection to the OpenShift machine, we use OCI command to fetch all the necessary details. So this is the first step to discover your entire environment within the Applications Manager. So with these monitoring capabilities, we can effectively track OpenShift environments and keep them optimized for performance and then the scalability. Now we will move on to the UI and explore what are the informations that we need to provide to onboard the OpenShift monitor within the Applications Manager. So as I told you previously, the OpenShift monitor helps to track the health, performance, and then the resource utilization of your OpenShift clusters as well. So we just need to enter the display name here to a user-friendly name for the OpenShift monitor for easy identification. And then we need to provide the host name or IP address of the OpenShift cluster here. And then we have credential details. So using this, we just need to provide the credentials for SSH authentication. And we have an option here called public key authentication. It is only supported for SSH 2 only. So if we select this option, we just need to provide the appropriate SSH port number and as well as the prompt key there. And once we enter those informations, we'll be able to collect the major metrics using the REST API. So if you want to collect the major metrics, we can enable this option. So this enables us to collect the most major metrics that are available within your OpenShift environment. And also the data collection will be happen if we enable this option using the REST API instead of SSH. And then the OpenShift username and password. We just need to provide the appropriate username and password here to fetch the informations within your OpenShift environment. And finally, we have the option called major specific projects. If you want to enable this option, we'll be able to view the filter condition here. Yeah. So if you want to monitor any particular project names, we can mention here. And then we'll be able to monitor those specific projects here. And we have timeout option here. And finally, we have polling interval. So for each and every monitor, we have a separate polling interval option to fetch the real-time informations within your target machine. So once we provided these informations, we'll be able to onboard this OpenShift monitor within the Applications Manager. So once we provided these informations, the monitor will be visible like this. So like I previously explained, like under the overview tab, you'll be able to view the availability of your OpenShift cluster and then the cluster usage details. If you want the detailed information of a particular available cluster, like memory usage, if you click on this, you'll be able to view the detailed information here, like the historical informations of your particular cluster memory. So similar to this, we'll be able to view all the informations for each and every monitor type and as well as for the supported attributes as well. So the basic informations will be listed here similar to other monitor types like component details and then the OpenShift summary details and all. And if you want to dive deeper into your OpenShift cluster environment, we can move on to the next steps. Like under the project tab, you'll be able to view the project details, like the project status, the live status, and as well as the project description. In this demo environment, the project description is not available here, but in your environment, the project description will be detailed, will be presented here in a detailed manner. And for each and every project details, we'll be able to configure the alarms as well. And apart from this, if you want to verify your node details, we'll be able to view the node details in a graphical representation view. And then if you want to verify the node memory and then the CPU details, we'll be able to view the detailed informations of each and every memory and then the CPU details here. In this demo environment, only one node memory and CPU details, it is presented within the OpenShift cluster. So that is presented here. In your environment, all the node memory and then the CPU details will be listed here. And for each and every memory and CPU details, we'll be able to configure the alert, and also we'll be able to view the health history of those attributes. And if you want to verify the node pod details, we'll be able to view the information here. And finally, we have node details here. Major role here is like we'll be able to monitor the pod details within your OpenShift environment. So under the pod details, you'll be able to view the detailed overview, like the project name and as well as the pod node name. Like we'll be able to view the real-time information that is visible within your OpenShift environment. And apart from this, for each and every pod, we'll be able to view the pod status and as well as the prod pod start time and as well as the created time. So using this information, we'll be able to configure the alarms. If there is any particular pod status, it is in the down status, or if it is in the pending status, we'll be able to configure an alarm here. If you want to view the detailed graphical representation view, the top 10 pod details for the CPU details will be listed here. If we scroll on, we'll be able to view the pod memory and then the CPU details here. Under the container tab, you'll be able to view top 5 containers by the restart count. Apart from this, if you want to verify the container details, we'll be able to view those informations. So without deploying any agents, we are able to view all this information, and we are able to view all this detailed insights within your OpenShift environment, and it is listed here using the SSH method. And under the services tab, you'll be able to view the service details and then the deployment details. Also, we'll be able to view the replication controller details as well. And if you want to check the health history of your replication controller, we'll be able to view the detailed insights from here itself. When I click on this particular, if I click on this particular replication control details, and if I want to verify the health history, we'll be able to view those. Apart from this, if you want to compare the reports for each and every metric, we'll be able to compare those reports and reports as well within this tab. Similar to the replica details, we'll be able to view the job details within your OpenShift monitor. So with this information, you will be able to view the real-time informations of each and every jobs that is running within your OpenShift environment. And finally, we have persistent volumes claims. So under this, we'll be able to view the project name and PVC status and then the PV name here. So if there is any request that is happening for individual PVC names, we'll be able to view those informations here. So these are the metrics and attributes that are available within the OpenShift monitoring. So we'll move on to the Prometheus integration. So for now, for the second method, we've introduced Prometheus integration in Applications Manager. So previously, we only supported Prometheus integration. So previously, we only supported Prometheus integration for discovering the Tomcat. But in the most recent versions, we've expanded this capability to include OpenShift monitoring as well. Now, we all have a question like why this is important. So, well, for security reasons, some users may not be able to establish an SSH connection to fetch the OpenShift data or execute the OCL commands. So to address this, we now offer this option to integrate the Prometheus directly using the exposed Prometheus API. So this means we can fetch the key OpenShift metrics seamlessly without the need of SSH. So if there is any secure environment and if there is no establishment for the SSH, we can go ahead with this Prometheus integration option. So optimizing the cloud performance. So now let's jump into the final topic of our webinar. So far, we've discussed how to track the critical KPIs across your container orchestration platforms. So now let's shift our focus to something equally important, like addressing performance issues and improving the efficiency of your cloud environment. With the right strategies in place, you can optimize the resource utilization, and also you'll be able to reduce the latency and ensure that your applications run smoothly and cost efficiently. We have automate repetitive tasks. So automating the cloud operations. Now let's talk about the automation here. So one of the most effective ways to avoid the manual work and also to improve your efficiency, we need automation. So imagine you have more than 100 virtual machines in your environment. If a few of them unexpectedly goes offline, manually logging into the Azure portal to restart them would be hassle, right? So with Applications Manager, we provide automated actions that can restart specific Azure VMs or Amazon EC2 instances when they are in the down status without any manual intervention. So this is not only saves time, but also ensures that your critical systems remain available without any delays. So using this automate repetitive tasks, we'll be able to avoid the manual intervention. Managing the cloud cost efficiently is just as important as optimize the performance as well. So cloud expenses can fluctuate significantly, and also if not monitored properly, they can exceed your budget as well. So within the Applications Manager, you can stay informed about your cloud spending, tracking where you spend the most money, and also you'll be able to identify the cost heavy services. So this proactive approach helps prevent cost overruns and gives you better financial control over your cloud and cloud resources. So no one wants unexpected outages, right? So they can cause downtime, affect the users. To prevent this, Applications Manager helps stay ahead with this. So we have a threshold and alerts option. So you can set limits for things like CPU and memory usage. If something goes beyond the limit, you get the notified. You get notified instantly. So instead of manually restarting a failed services, you can set up an automatic restart to trigger a specific actions when a threshold is breached. For example, if a cloud instances crashes, the system can reset it automatically. No need to log in and fix it yourself. So this saves time and ensures the smooth operations as well. So from here, we'll be able to view two different snapshots here. So when running Applications Manager and as well as the applications within your cloud, the performance issues can be tricky to catch. So that's where APM Insight comes in. So using this service map feature, we'll be able to view the clear picture of all the components involved. So you can easily track how different services are interacting within your applications. So this will also help us to foster troubleshooting as well. By identifying any performance bottlenecks early, you can fix issues before they impact the users. Quick recap. Before we wrap up, let's do a quick recap here. First, we discussed about how to proactively monitor your AWS cloud applications. So this helps us to track the performance metrics, detect slowdowns, and ensure smooth operations. And apart from this, we'll be able to monitor proactively your AWS cloud applications. This helps us to track performance metrics, and also it helps us to detect any slowdowns and ensure smooth operations. And second, we discussed about how to keep track of your Azure applications. So using this, we gain insights into application performance and optimize the resources and improve the efficiency. And we discussed about how to track critical KPIs for container orchestration. Whether using Kubernetes or any other platforms, monitoring KPIs helps us to identify any issues early. And finally, we discussed about pinpointing performance bottlenecks within your cloud environment. So by continuously monitoring, it helps us to detect slowdowns and also troubleshoot issues. And if there is any enhancement kind of performance that is occurring within your environment, we'll be able to pinpoint the performance bottlenecks here. So with these capabilities, you'll have better visibility and control over your cloud applications. This ensures optimal performance and reliability. Also, thank you all for joining. We really appreciate your time. Take care and thanks again.